In this tutorial, I'm going to teach you how to construct the Argand diagram. Now, one of the first things that we need to know about the Argand diagram is that it is a graphical representation of a complex number. And it was developed by a French mathematician, Jean Robert Argand. So, and it goes in this format. Don't forget, the general form of a complex number is A plus IB, where our A represents the real part and our B represents the imaginary part. Now, the first thing that we need to know is that the real part corresponds to the x-axis. That is, the real part corresponds to the x-axis, while the imaginary part corresponds to the y-axis. So again, the general form of a complex number is A plus IB. So for example, if we have a complex number, let's say it has a real part of 3 and a complex part, let's say I7, it means that on your x-axis, you are going to locate point 3, and on your y-axis, you are going to locate point 7. So what happens in the case whereby you have minus 3 minus I7? It means on the x-axis, you will locate your minus 3, while on your y-axis, you are going to locate your minus 7. Now, basically, if we have a simple, let's consider the Cartesian coordinates. Let me just give a short sketch. This will be our y positive. These are our y negative. These are our x positive. And these are our x negative. Now we know that if we are to represent a complex number z, let's say we are dealing with a complex number z, for example. I don't want to represent a complex number yet because I'm going to do some series of examples to explain that. But let's assume that we have a complex number z, for example. Now, to represent this, let's assume that the values of the real part and the imaginary part falls in the first quadrant. It means that the general representation of a complex number actually tallies up with a straight line. That is, the straight line is the graphical representation. A straight line will be the graphical representation for z. And the plane in which it is plotted against is what we can refer to as our complex plane. Now, what exactly am I trying to say? Let's assume that this is the straight line that we have plotted to be our z. If we trace this to the x-axis and we trace this to the y-axis, now, tracing this to the y-axis, this is going to give us our real parts. You know, I told you that, that will give us our imaginary parts. I told you that the imaginary part corresponds to the y-axis, while the real part corresponds to the x-axis. So, and don't forget, if we are using that basic representation, it means we refer to these as our B and these as our what? As our A. So basically, I'm just using this as a sketch diagram. We are going to draw series of diagram to actually explain different complex numbers and how you can represent it using an Argand diagram. So without wasting much time, let's draw an Argand diagram for some complex numbers. Okay, so we want to draw an Argand diagram for the following complex number. The first one that we have is 2 plus I3. That is, our z is 2 plus I3. So here, our real part, which corresponds to the, from diagram I gave earlier, your real part corresponds to the what? X-axis. So this corresponds to the x-axis, and your imaginary part corresponds to the what? Y-axis. Now, don't forget our x-axis from the general form of a complex number, which is z is equal to a plus ib. It means our a here represents plus 2 and our b here represents plus 3. Now take a look at this graph. We are locating 2 on the x-axis. This is point 2. It means that we are going to have a line extending up here. Then we are plotting 2. It's just more like, let me put it like this. You are looking for a point first, and that point is going to be a comma b. You should notice that every point is a combination of 2 coordinates. So what is actually happening here is that the coordinate of the point you are searching for is 2, 3. So now you are trying to locate 2, 3 on this graph. Now your x is 2 and your y is 3. It means that 2, 3 is going to be at this point. So if we trace this to the point and we trace this back to 2, now we take from the origin to that point. It means that this is going to be our z1, which will be the Argand diagram for z1. Now, there's an important reason why we actually need to sketch the Argand diagram for complex numbers, because when we get to the polar form of a complex number, where we have to find arguments, then the angle of inclination, you will discover that we are going to need sketching the Argand diagram, because if you are measuring your theta, you always measure theta from the horizontal, or let me say from the OX plus axis. For example, you know that this 0 is our origin. Now, if I am to add something like this, this is our x positive, and these are our y positive. While this other side, these are our x negative, and these are our y negative. So if you are measuring angle, for example, the angle theta for this particular complex angle is measured from this O. Okay, we have 0 here, but the O that I'm saying is referred to as origin. This O is referred to as what? Origin. That's the O I'm saying. So you measure theta from the OX axis. So which means is that from this horizontal OX axis, you are going to measure the angle until you get to that complex number. So, okay, that curve is a little bit weird. Let me draw that again. I want to make sure I start it from the OX. Okay, so this is a bit better. From this OX axis to this complex number, this is going to be your theta. So if you make an idea, because you know that from SOHCAHTOA now, this is going to be a 90-degree angle. You can easily find theta using tan to be your opposite over your adjacent. You know, you don't know hypotenuse. Your opposite here is going to be from here to here, which is 3. Your adjacent is from here to here, which is 2. Distance between these 2 points. So basically, that is one of the major reasons why we need to draw an Argand diagram. So, but in this particular section of the tutorial, we are just going to sketch how to sketch the Argand diagram. So in the next tutorial, in the next video, you are going to now see how we calculate angles, arguments, leaving a complex number in its polar form, using the shorthand representation, and a lot more. So let's move to the second example that we have there, which is b is equal to, that is our b part. Our z2 is equal to minus 3 plus i2. So the same approach here, using the same approach, this is going to correspond to your x-axis. This is going to correspond to your what? Y-axis. So it means that the point you are looking for is in the form minus 3 comma 2. So don't forget, this is our y positive, this is our x positive, this is our x negative, and these are y negative. So if we are to illustrate minus 3 on the x-axis is at this point, plus 2 on the y-axis at this point. So it means that this is going to give us the point minus 3 comma 2. So now tracing this will give us this. Tracing this also to 2 to make sure that it gave us that point exactly. So now taking it back to the origin, this is going to be our what? Z2. So for example, now you know that this is the origin O, this is the x positive, so this is the OX plane. So if you are to measure the angle for this complex number Z2, the angle is going to start from here down to the what? Complex number. So this is going to be our theta. So that's why, for example, questions like this, if you call this angle E, and you now use your tan E is equal to 2 over let's say minus 3, so but we can just put 3, and you find the value of E. So this value is not going to be your angle, that is the angle you are going to use in the polar form. I'm a little bit entering polar form, but I just want you to understand this so that when you watch the other tutorial video, you'll be able to understand properly. So when we have r is equal to cos theta plus I sine theta. So if you use this theta to be this angle E, that is what you get from here. You're going to get a wrong answer because your theta here is now going to give you 180 minus E. So they don't just assume this thing. It's from the Argand diagram that you'll be able to decide, that you'll be able to get the particular angle that you are going to actually use. So that is, I've told you, that's one of the very important reasons of drawing an Argand diagram. So let's move to the next example, which is example 3, and we are trying to represent our Z theory. So the same approach, this is going to correspond to our x-axis, this is going to correspond to our what? Y-axis. So the point we are looking for here is kind of a point 4 comma minus 3. So we are dealing with, okay, let me label this. These are y positive, these are our x negative, these are our x positive, and these are y negative. So if we are to locate 4 comma minus 3, 4 on the x-axis, that's the positive x-axis, then minus 3 on the negative y-axis. So this point is going to come downwards. So 4 and minus 3 is going to be at this point. So let me just illustrate those dotted lines, showing that we traced it to all those points. So from the origin O, drawing a line to that point is going to illustrate our Z theory. So the same thing here, from your positive OX axis, if you draw your angle theta, is going to start from the positive OX axis and it will keep on going until it gets to what? Z theory. So it means that if you call this angle E, the angle you get from SOHCAHTOA, our theta here is actually going to give us 360 minus theta. So you can see the dynamics now. Moving to Z4. So now the same approach. We have our y positive, we have our x positive, we have our y negative, we have our x negative. So here the part corresponding to x-axis is our minus 4, the part corresponding to y-axis is minus 5. So we have minus 4 comma minus 5. So representing x on the negative x, representing -4 on the negative x-axis is going to be this point. Then -5 on the negative y-axis. So this will go down, and this will be at this point, -4, -5. So using a kind of short dashes to locate this to that point, then also to -5. So it means from our origin O, the straight line representing the complex number. So this is going to be Z4. So our Z4 here is our -5 minus I5. So from the positive O x-axis, your angle theta will start from that O x-axis, and it is all going to come what? Towards the line for that complex number. So for here now, let's say you represent this your angle as E, you discover that your theta here is now going to give you 180 plus E. So basically, this has covered how you can represent a complex number using the Argand diagram. If you have questions, you can drop it in the comment section. I'll be more than happy to give an explanation to your question. And if you have not watched the first two videos on complex number, it's advisable you do that so that you get a sequential, a procedural concept about the topic, so that you leave no stone unturned. So I'll see you in the next tutorial video. Thank you.